Okay, number 2 is really easy to do, but so many students get confused with this one on section 5.2. Now, you could use long division, but I don't recommend it. The easiest thing to do is to recognize that there's only a monomial in the denominator, which means that you could take that monomial and put it on each of the terms and creating, it's kind of like making 3 fractions out of 1 and simplifying each of the fractions, right? It's kind of like if I had 2 plus 4 divided by 2. Well, we already know that that's going to be 6 divided by 2, which is 3. Well, another thing that you could do would be to split the denominator and make it 2 over 2 plus 4 over 2, and it would still be the answer 3. Does that make sense? So that's exactly what we're going to do with number 2 above. We're going to split that denominator into 3. That way it'll look like 3 fractions, and then we're going to simplify from there. So the 6k squared m is going to be over 2k m squared. Then you have a minus 12k to the third m squared over 2k m squared. At the very end, plus 9m to the third over 2k m squared. You just took that denominator and wrote it 3 times underneath each of the terms. Then after that, you could cancel things out. If you look at the numbers here, 6 over 2, that's a fraction. You could reduce by 2, or you could think of it as 6 divided by 2 is 3. So you have a 3 left over up on top if you want to start writing your answer. And then you have your k's. There's 1k on the bottom and 2 k's on top. So the bottom k completely cancels out with one of these, and there's going to be 1k left up on top. So you put the k up there. And the m's, same concept. There's 1 m up on top, 2 on the bottom, so 1 m cancels with one of these m's, and there's 1 m left on the bottom. Yay? Let's do the same for the middle fraction. The 2 on the bottom cancels with the 12. There's going to be a 6 left over up on top. So the second fraction, you're going to have a minus fraction bar, 6 up on top, and the m squares both cancel out. 2 m's on top, 2 m's on the bottom. And then you have your k on the bottom that cancels out with one of the k's up on top, which means you have 2 of them left over. So you really have k to the second left over up on top. Another thing is you don't even need that division bar because that's actually 6k squared over 1, so you could just write it as minus 6k. Or you could put it over 1, it doesn't really matter. Your third and final term right here, you're going to cancel out the m squared on the bottom. 2 m's cancel out with 2 of these 3, and there's going to be 1 left over. What else? There's nothing else to cancel, so that's your third term, a plus fraction 9m over 2k. So this whole entire thing is your answer. 3 terms, 3k over m minus 6k squared plus 9m over 2k. Are you with me? Easy? So number 7, you can't use synthetic division because the binomial on the bottom has an a value other than 1. So you're going to have to actually do long division. So that's how you set it up. And then after that you think, look at your first term, 2x. 2x times what will get you a 4x squared? You want the identical value. 2x times what will get you the identical 4x squared? That's going to be a positive 2x. And notice I'm going to write the positive 2x right on top of the other x's here. Okay. So when I distribute 2x times 2x, it really does give me a 4x squared. And when I distribute the 2x times negative 3, that's going to give me a negative 6x right there. Now before you start combining, remember, after all, we are subtracting this value, so you need to put parentheses with the minus sign out there. That way you could distribute the minus sign, it'll change it there, it'll change it to a plus. These guys cancel out, you end up with a positive 4x, and then you simply bring down the plus 6. And once again, you think 2x times what will get you that exact value 4x? 2x, right? So we're going to put another, actually not 2x, just 2. You're going to put plus 2. And notice that I wrote that 2 on top of the number 6 so we can stay organized. So when we distribute 2 times 2, that's 4x. And then when we go 2 times negative 3, that's negative 6. Now, a lot of students make a mistake right here. They just cancel everything out. But remember, you are subtracting. You need to put parentheses around the whole thing. Distribute the minus sign. That way it'll be a negative 4x, which will cancel. That way it'll be a positive 6x, which actually becomes positive 12. So your answer is this guy up here, 2x plus 2, but you need to throw in the remainder. So it's a positive 12, so you're going to put plus, and you're going to make it a fraction. The 12's on top over the original divisor, 2x minus 3 on the bottom. What do you think? Let's go to one where you could just do synthetic division instead of long division. So it's as easy as this. You make your box, and whatever you're dividing by, remember it's a binomial x minus 2, so inside the box it's actually going to go in as positive 2. And then after that you take the coefficients, and you have to have them all represented. There's a power of 2, power of 1, then the constant. So everything's represented. Just write down the 2, the 3, and the negative 14. So that's why I'm going to put a 2, a 3, and a negative 14. Then you draw your line, and then it becomes as easy as this. 2 going down, 2 plus 0 is 2. And then 2 times 2 is 4. And then 3 plus 4 is 7. And then 2 times 7 is 14. And of course, this is your remainder part over here. And negative 14 and positive 14 is 0. So what's our answer? All you got to do is go back to your values here, and you would write it as 2x plus 7. Remember, the last one has to be a constant. The one to the left of it has to be an x. If you had more over here, then it would be an x squared and then x to the third and so on and so on. Now, if you did have a remainder, you would have to put plus the remainder over the original divisor, x minus 2. Like, for example, let's say you had a 1 as the remainder, then you'd have to go plus 1 over x minus 2. But that's obviously not the case. There is no remainder of 1, it's 0, so you're not going to put plus the remainder, you're just going to leave it like that. Let's try one more where we could do long division, but it works out nicely. Oh, I'm sorry. Yes. Let's do number 8, and you have to use long division because you have a variable out here. The a value, or the leading coefficient of the binomial that you're dividing by, is 2. If you wanted to use synthetic division, you'd have to have the a value of 1, or the leading coefficient of 1. So we can't go with synthetic division. It becomes too complicated. So we're going to go long division. So this is how we set it up. There were no missing values. It's power of 3, power of 2, power of 1, constant, perfect. So there are no missing values. If there were missing values, you'd have to fill them in with 0. And then you start thinking, okay, 2 times what will give me a 2r to the third?
R squared.
R squared. So you're going to put an r squared as the first part of your answer on top of the other r squares. Then you're going to distribute r squared times 2r. That is the 2r to the third that we wanted. And then when we distribute 2r times a negative 3, that's going to be negative 3r squared. And of course we are subtracting, so I would put parentheses with the minus. That way it'll remind you to distribute there, and that'll cancel, and distribute over here. That'll become a plus. You'll actually get an 8r squared right there. And then we bring down the minus 2r. Then we go back and think once again, 2r times what will give me an 8r squared? 4r. So let's put a positive 4r up there. And let's distribute positive 4r times 2r. That'll give me the 8r squared that I wanted. And then the positive 4r times negative 3 will give me a negative 12r. Now again, you have to remember that you are subtracting here, so you have to put parentheses with the minus. That way you could distribute it in, which means it cancels, and distribute it in, which means it changes to a plus, which means that you have 10r, and then you'd bring down the minus 15. And for your final step here, you would have to multiply 2r times what to give you 10r? 5. So you put plus 5 because the 5 is positive that we're multiplying by. And when we distribute 5 times 2r, that is 10r. And we distribute 5 times the negative 3, that's negative 15. And again, we're subtracting, So when we subtract, we put in parentheses and put the minus, which means that there is no remainder. So here's an example. I mean, I know you guys hate long division, but here's an example that works out nice and neat. The remainder is 0. So there's your answer, r squared plus 4r plus 5 for number 8. Let's check these guys out down here. Number 1, state the degree. What's the degree? The degree is the highest exponent. What's the degree?
Highest exponent.
And what is the highest exponent on number 1? 1. The highest exponent is 1. The a to the 1 power, right? Okay, what's the leading coefficient? Leading coefficient. It's 1, the number that's in front when it's in order. So the leading coefficient is also 1. How about, what else does it ask for on the instructions? Leading coefficient, constant. What's a constant on number 1? Constant, I'm going to put it as C. C, that's 8. Okay, piece of cake. And then it asks us to classify, and that's it. So what's the first name? It's linear, because it's the power of 1. And what's the last name? Binomial. Why binomial? Because there's 2 terms. 1, 2. There's 2 terms. Let's move on. Number 2. In order to do this, you need to first distribute to get it in standard form. So you go 2x times 4x, that's 8x to the third. 2x times 3, that's 6x. Distribute negative 1 times 4x, that's negative 4x squared. And then negative 1 times positive 3, that's negative 3. And of course it's out of order, so let's put it in order. In standard form, you're going to have an 8x cubed minus 4x squared plus 6x minus 3. And now you could go through and answer those questions. The leading coefficient, what's the leading coefficient? 8. What's the degree? 3. What's the constant? Negative 3. And what do we classify this as? Cubic polynomial. Because there's the degree is 3, that's cubic, and there's 4 terms, 4 or more is polynomial. You guys get it? Number 3, kind of curveball right here. What's the leading coefficient? Negative 1. The degree? 4. Now keep in mind, guys, the leading coefficient is the number that's out in front when it's in order. This guy's not in order. The leading coefficient's not 8 because this guy technically should be rewritten out here in the front. So your leading coefficient is really the negative 1 right here. Okay? And of course, constant. The constant is still negative 10. And your classification is a quartic polynomial. Because there's 4 or more terms. Last one. The degree. What's the degree? 1. Leading coefficient? 5. Constant. What's a constant? 0. There is no constant. Classification? Linear monomial.